FLIR has brought out another new acoustic imaging camera, but unlike the Si2 series, the Si1-LD has fewer microphones, a shorter detection distance, and a narrower frequency range. Yet it still promises an excellent return on investment. How? The FLIR Si1-LD acoustic camera has reduced its microphones by 23%, its detection distance by 35%, and its frequency range by 23% compared to the Si2-LD. So what's the point of it? Why is it a good investment? Here to tell us about who and what the FLIR Si1-LD acoustic camera is perfect for is Jason Cargil, FLIR's technical sales specialist. Welcome, Jason.
Hello, Thank you.
Hello. So this time we're talking about the FLIR Si1-LD.
Yes.
But before we talk about that, please could you give us a brief overview of acoustic technology and its benefits?
To put it simply, acoustic technology allows you to see sound. Mm-hmm. And, you know, when you put that in a sentence, it sounds quite strange. How do you see sound? But ultimately, having a device with an array of microphones, which allows you to triangulate, locate, and actually identify where a leak is from a distance, that's kind of in its simplest format. That's what you do with acoustic imaging generally.
And we're talking about compressed air leaks, aren't we? Not water leaks.
Exactly. We are pressurized. We call them pressurized gas leaks, but the gas in the case of the Si1 would be compressed air.
So as mentioned, there are some key differences between the Si1-LD and its Si2 counterpart. Please, could you talk us through these differences?
Yep, certainly. So the Si1 has been introduced with a smaller amount of microphones. Yep. So there's 96 microphones in the Si1 as opposed to 124 in the Si2. But the principle is still the same. You know, it's still, the device is still listening out for the sound source created by turbulent air movement. So we have a lower number of microphones in the array, but that's not a bad thing. We also have a different bandwidth which we operate within now. So whereas the Si2 would operate from 2 kilohertz to 130 kilohertz, the Si1 will operate between 2 and 100 kilohertz. Mm-hmm. And again, not necessarily a bad thing, because the majority of compressed air leaks in particular I've been present at when we've done demonstrations, comfortably between kind of 20 kilohertz and 60 kilohertz is a typical kind of frequency range that we come across. So we have now up to 130 meters detected in distance as opposed to 200 with the Si2. Yeah. But bearing in mind, we're talking about compressed air users. Generally, they're within a site. Yeah. The chances of being 100 meters away, even from a target, is relatively small. Yeah. You tend to be a lot closer than that, probably less than half that distance. So again, the difference in detection distance is not an issue for a lot of users. So they're the main differences in regards to specifications.
So we've mentioned how the Si1 compares to its Si2 counterpart, but it does actually build on the capabilities of FLIR's original Si124-LD Plus.
Yes.
Could you talk to us a bit about that?
Yeah, so we've built on the first iteration of FLIR with the Si124, where now we have a far more capable piece of equipment. So it does have a wider bandwidth than the Si124 had. The Si124 had a black and white display. Mm-hmm. We now have a colour display, which is also 12 megapixel, with the ability to zoom in up to 8 times as well. So therefore, when you zoom in on a higher resolution image, you don't get the same type of pixelation that you could suffer from. There's also the LED lamps, which are also included with the Si1. So if you're working in an environment where there's low light conditions, it's no good having a 12 megapixel display if you can't see anything.
Exactly.
So the built-in LEDs are also a big feature. And also one of the biggest features we've introduced is we now have what's called manual band pass filtering. Okay. So whereas the camera still has the ability to move within certain bandwidths in regards to location of particular sources of a leak, we now have the on-screen capability to scroll across a bandwidth selection. So what that means is you might have a sound being generated by something that's not a compressed air leak. So it could be a mechanical problem, for example. The manual band pass filtering will allow you to isolate to actually enhance the target that you're interested in. Yeah. So it just gives the user more flexibility, more functionality on screen to be able to isolate. So the microphones are installed in a certain array, which allows them to maximize the source so that the location is accurate. Yeah. And obviously the information from the quantification is also accurate. But it works on something called beam forming.
Okay.
And beam forming basically means that you may detect a sound from a particular position. And that means one of the microphones will receive more of that sound pressure than maybe the one next to it.
Okay.
And that goes on throughout the whole array. So ultimately, this is how the cameras are able to really locate accurately using this beam forming technology, which is a thing which is in acoustics anyway. So if we look at the overall introduction to the SI1, we've got a device which is more capable than the SI124.
Yeah.
It's got a lot of additional features which the SI124 didn't have. It might not have as many features as the SI2, but then that's reflected in the cost point, and it's been competitively priced to really be excellent value for what you get in this piece of equipment.
Yep.
And overall, if you're looking at compressed air issues, you know, we're not trying to replace traditional ultrasonic technologies, but these devices, and now especially with the upgrades in the SI1, allow you to find those potential leaks quickly, because ultimately it's not just about finding leaks for lost energy. It's also the knock-on effect that has on your compressor equipment, for example. So the air that you're generating, if you're operating a system where you've got a lot of leaks where there's air escaping, your compressors then have to be turned up effectively to work harder to generate the level of air that you need within your site. So you do have an energy loss, but then you've also got the potential longevity of your compressors being reduced. So anything you can do to enhance the longevity means that you get a longer period of time with your compressor generation equipment being operational. If you look at it overall from a compressed air perspective, there's different reports about these things, but certainly 25-30% of compressed air which is generated is lost. Yeah. Some of it through leaks and some of it through for other reasons as well. But ultimately, anything you can do to locate those leaks and fix them. And this is what we find with some of the users of these devices. It's not always about the quantification and the energy cost. Sometimes it's about find and fix fast.
Yeah.
So ultimately, if you can find the worst leaks that you have and you can fix them quickly, that's the sort of the first protocol. And then someone who maybe is an energy stakeholder within a particular site or a manufacturing organization is more interested in the energy cost. But with this device, you've got the ability to do both. Yeah. You can find and fix fast, and you can also quantify to work out what the cost savings are as well.
To find out more about the FLIR Si1-LD acoustic camera, click the link in the description, where you'll also find an option to purchase. Alternatively, click the box above to download the spec sheet. Up next, we'll be finding out if the Si1-LD's reductions have affected its accuracy, efficiency, and ease of use. The Si1-LD is specifically designed for detecting compressed air leaks. And like the Si1-2 and Si1-24, it has a leak quantification function. Please, can you tell us a bit about that?
So one of the key features with acoustic imaging technology is the ability to quantify the cost of losses. Mm-hmm. Now, with compressed air, this is usually done by entering the kilowatt hour cost into the camera. So, for example, if you're paying 20 pence per kilowatt hour, you can enter that number into the camera. And then when you have your quantification cost calculated internally within the device, it gives you an accurate, don't get me wrong, it's not to the penny, but it's a very, very good indicator in regards to what type of costs are being lost over a year. Mm-hmm. So essentially, that's really what the quantification side of the acoustic imaging technology is for.
So it's good for prioritizing faults, leaks that need to be fixed quicker.
Yeah, so you can essentially see which leaks are the worst.
Yeah.
Because ultimately, it's kind of a question you might get asked as well. What happens when you fix all your leaks? Well, the simple fact is you never will. Because the nature of the beast is that when you have a bad leak, and it's the biggest contributor to your air loss, when you fix that leak, that then creates pressure in the system, which will make the smaller leaks a bit larger.
Yeah.
So it's kind of, there's a continuous process of improvement with the leak location, identification and quantification.
Yeah.
But ultimately, it can then be down to the user to dictate which ones need to be repaired first. Because in knowing what it's costing, but also how many litres per minute you're losing. And also the third factor is the decibel level. So the sound pressure level is also an indicator. But you can really then design, okay, what's the repair program? Because there is the ability to use the acoustic software, which is free. Yep. And it's in a cloud-based service, which comes included with the camera. Allows you to then also have a date using a calendar to say, well, okay, we located this particular leak on the 1st of January, and it was repaired on the 3rd of January, and that then also goes into the report using the software. So it's prioritization and having a program of repair which fits in with the resources that people have at the time.
Okay, so now Mike, and I don't know if you remember Mike, he was the disgruntled maintenance engineer that we talked about during our SI2 interview. Well,
so he's back.
He's back.
Oh.
He's back, and he wants to know how the reduced microphones affect the SI1's accuracy.
This will be a question customers may ask. People who are considering looking at, well, okay, more microphones was better. That must mean that less microphones isn't as good. Well, the simple fact is it's all down to the application and the actual targets that you're looking at and what you're trying to achieve. The simple fact is this device, the SI1, the latest introduction, specifically compressed air, the microphones which are used have been enhanced. So these are called MEMS microphones, which is a micro electronic mechanical system. Okay. So this is a very low sound generator itself. So accuracy is enhanced from what the SI124 was.
Yeah.
Yes, there are less microphones and it does work over less distance and it does cover a lower band frequency. But ultimately, for what it's designed to do, it's been enhanced in a way that it can do that task very well. So customers and users and potential users shouldn't be concerned about the number of microphones because there are other acoustic imaging technologies out there now which have less microphones than the SI1. The fact is they still do a job. But the SI1's been designed in a way that the additional functions that we've added, even simple things like the better display and the built-in LED lamps, these all together combine to ensure that the user still has a very, very good solution for locating, quantifying, and ultimately repairing compressed air leaks.
So Mike should not be concerned.
Mike should not be concerned.
So another thing Mike wants to check is, last time you were in, you talked about how you gave the SI2 to some maintenance engineers and you gave them a 10-minute talk and then they could go off and collect all the data that they needed or wanted. That was a story you told us last time. And Mike wants to know if the SI1 is as easy and efficient to use.
Yes, in one short answer. But ultimately, what I referred to last time is it's a case of you can be up and running with this device and the SI2 relatively quickly. And there have been cases where, because I've not been able to get on site, I've shown someone the basics of operating the camera, and literally we're talking within minutes, you can be up and running to capture some data. There's obviously a little bit more involved in regards to what you do with the data and how you attach comments and what have you on the screen.
Yeah.
But yeah, it's literally that quick because ultimately you're not expected to be an ultrasound specialist. The idea is the device does the work for you. The device is locating, triangulating, trying to enhance what the source is. You know, you've got this ability now with these manual bandpass filtering to be able to really home in on a particular source. So from that perspective, this technology is designed and in reality is easy to use from a very early stage.
Coming up, we're going to be talking return on investment and why the ROI is so good on the FLIR Si1-LD. In the meantime, remember to click the box above for the datasheet or the link in the description to purchase. So considering the features and capabilities of the Si1 and especially how they compare to the Si2 and Si124 counterparts, what would you recommend this camera for, or who would you recommend this camera to?
Let's use a broad brush to begin with.
Okay.
Anybody using compressed air.
Okay.
So that's a very easy answer to give initially. But if you're generating compressed air, there's a cost involved in that. If you're using that compressed air in a manufacturing process, there's a cost involved in that, especially if it's being lost. So the return on investment with these kind of devices can be relatively short. I mean, we've got cases on our own website in regards to testimonials and case studies where there's been a rapid return on investment. I've done demonstrations in the UK where we've had a rapid return on investment because the capability of the device, there's no faster way to find compressed air leaks. Traditional technologies may have more capability at the lower end and might have more sensitivity in certain scenarios. But usually some of these devices can also be more complicated to use. Yeah. They can be more costly. But as was mentioned earlier, the price point of this device is approximately 50% of where the Si2 equivalent is. Now, the Si2 is a far more capable piece of equipment, and it does a lot more. But again, what this does at this price point is extremely competitive. So compressed air is still the biggest factor in regards to users. So I would say anyone who's using generating compressed air, uses it in a manufacturing environment, there's a benefit to be seen with it, even with a demonstration of this type of equipment, because you will see how fast it can be in regards to the speed of identifying a leak.
So I was going to ask actually why the Si1-LD's return on investment is so good, especially given the reductions in some of its capabilities. So would you put that down to its efficiency, ease of use?
I think, well, it's all down to what capabilities you actually need.
Yeah.
You know, the simple fact is this technology is designed for pressurized gas systems. So we use the term gas, but gas includes compressed air.
Yeah.
So there are certain scenarios where, let's just say, a typical site I've worked on had to maintain a pressure level of 6 bar of pressure. That's a pretty pressurized system. And any leaks in that kind of environment, they're going to show up quickly because of the additional sensitivity of the Si1 compared to its predecessor.
Yeah.
So the less number of microphones is not as much of a concern to users in that scenario. It's a bit like thermal imaging cameras where we talk about the size of the detector. And the simple fact is, a 640 by 480 detector is going to give you better results generally than a 160 by 120 detector. Well, it will do every time. But ultimately, it depends what the type of use is and what the type of target is. And if you're only interested in targets with high thermal contrasts, then a lower resolution camera is still very useful. If your budget can stretch to a higher resolution camera, we'd always advise trying to enhance the number of pixels you've got on your image, because more pixels on a thermal image is important. But ultimately, with this technology, a typical system pressurized to kind of the 6 bar level, those leaks are going to stand out really well. So the enhanced capability of the Si1, with the better screen, with the additional bandwidth over the 124, with the additional distance over the 124, is going to still be a very competitively placed product in the acoustic imaging range, which is available now and has been enhanced in the last 2 years in particular. As a whole, I don't just mean with FLIR. There are a number of options out there. We still opt for this single pistol grip camera. You know, from a user perspective, it's still very easy, very nimble to use. Some other models will have 2 hands needed to use the device. Some people will like that, some people won't. It's down to personal preference. But the price point with the capability and the enhancements gives us a very, very competitive, useful package in regards to the Si1.
Remember, box above for the datasheet, link in the description for our web listing. So is there anything else you think we should know about the FLIR Si1-LD acoustic camera?
Well, I kind of touched on it before with the software. So when you invest in one of these cameras, you automatically have access to what's called the FLIR Acoustic Viewer.
Yeah.
So the FLIR Acoustic Viewer is a cloud-based service where you can link your camera to your account.
Yep.
And the images which you captured on your Si1, in this case, will be transferred to your cloud account either wirelessly, or they can be stored in your device and then they can be downloaded to a USB, because there's a USB port in the top of the camera. But having access to this cloud-based service, this FLIR Acoustic Viewer, means that you can do some analysis on your images and you can create very simple PDF reports as well. So that's free. But also, you will have a plugin provided with the camera, which gives you access then, if you're using FLIR Thermal Studio, the plugin allows you to also download your data from your acoustic camera and ultimately use Thermal Studio to create reports as well.
And that's is that an analysis? Can you use the analysis functions in that as well?
It's not the same as a thermal imaging result, because the technology is different, the results are different, but you still have the ability to generate reports. Some customers mightn't want cloud service. Some customers don't like cloud accessibility. They want something which is loaded onto a desktop. In that case, they can use Thermal Studio. So you have 2 options when it comes to the software.
Great. And so if you were to summarize the FLIR Si1-LD acoustic camera in 3 words, what would they be?
Great value now.
Thank you, Jason. That was insightful.
Thank you very much, Jess.
Thank you. Hopefully we've proven just what a good investment the FLIR Si1-LD acoustic camera is. To discover even more about the FLIR Si1-LD acoustic imager, click the link in the description, where you'll also find an option to purchase. Do check out all our past FLIR videos. We have a fair few of them now, including an interview with Jason about FLIR's Si2 acoustic cameras. And remember to subscribe, as that way all future videos will come straight to you, so you'll never miss an important development. Okay, thank you for watching, and we'll see you in the next one.